So for our third and final problem, we have this one. So Roger and Don were observing a parachute situated at point P or point B at this one. Okay, so this should be point B. Okay, so Roger was located at point R and Don was located at point D. Roger and Don wanted to know the distance of the parachute with respect to the ground. So let's say, for example, this is the ground where they were standing on, and this is the length of the parachute. Okay, the length of the height of the parachute from the ground. Okay, so that's gonna be x. Okay, given also we have another information here. From point R, Roger at an angle of 20 degrees moved towards Don at point D at an angle of 40 degrees. And Don was standing at an angle of 40 degrees looking at the parachute with a distance of 75 feet covered by Roger. Okay, so these are our additional information. We need to find the value of x. So how can we solve for the value of x for this one? Okay, we're going to be using angles of elevation and depression, okay, as well as the application of the trigonometric ratios. If we're going to try to recalibrate or try to draw it again in a much simpler scale, we have here Roger, we have here Don, we have here the ground, and we have here the parachute, and then we have here this angle measures 20 degrees, this angle measures 40 degrees, and side measurement RD measures 75 feet. So how can we find the measurement of x for this one, for this problem, the distance between points B and C, given y here for this problem? Okay, so as you can see here, guys, we cannot directly solve for the measurement of x here since there are no side measurements given here. There's only an angle given here, that's 40 degrees, but that's about it. There's no side measurements given on triangle BDC. So for this problem, what we can do, of course, is we have to look at the bigger picture. This right triangle that we have here, this big right triangle. So that's triangle BRC. And in triangle BRC, we can say that tangent theta is going to be equal to opposite all over the adjacent side. Okay, so for this problem, we need to find the value of x, and since x is opposite of 20 degrees on this big right triangle, its opposite side is x degrees, the one that we want to find. So therefore that's gonna give us tangent 20 degrees is going to be equal to the opposite side, okay, which is x, the one that we want to solve, all over the adjacent side, which is 75 plus y. Okay, now we have a problem. We don't know the value of y. So for this one, we have to look at the smaller right triangle that we have here on triangle BDC. So on the smaller right triangle, we have triangle BDC there. We can say, again, that we can use the tangent trigonometric ratio. Tangent theta is equal to opposite all over adjacent side. And since we know the value of theta for that one, that's equal to 40. So that's tangent 40 is going to be equal to the opposite side, which is equal to x, all over the adjacent side, which is equal to y. And to solve for the value of y, we just cross multiply. So that's y is equal to, y tangent of 40 is equal to x. And if we divide both sides by tangent of 40, we can get that the value of y is equal to x all over the tangent of 40 degrees. Okay, and since we know the value of y, we can now substitute the value of y for this one to have one variable, so that we can only have one variable for solving this problem. So that's going to be tangent of 20 degrees is equal to x all over 75 plus x all over tangent of 40. Okay, so we're concerned now here with the denominator. The denominator looks a bit complex, but we can add it just by using the normal rules for addition of fractions. So that's a all over b plus c all over d. So that's gonna be a times d plus b times c all over b times d. So for this problem, we can say, we can multiply the denominators here. So that's 1 and tangent 40. So that's gonna be, okay, tangent 40 all over, okay, so what's 75 times tangent 40? We can just write there, 75 times tangent 40. And then what's 1 times x, so that's just x. So therefore we have here this denominator and this complex fraction. So we have x all over 75 tangent 40 plus x all over tangent 40 is equal to tangent 20 for this problem. Okay, and since we have, we're going to divide the fractions here. Let's try to divide it on this side. So it's going to be x all over 1. And then remember that on the fractions rule, we have to flip the fraction. Since this is the one that we have to divide, the divisor for this one. So this is going to be x all over 1 multiplied to tangent 40. The reciprocal of 75 tangent 40 plus x all over tangent 40 is tangent 40 all over 75 tangent 40 plus x. Okay, so therefore that's gonna give us x tangent 40 all over 75 tangent 40 plus x, okay, is equal to tangent 20. And of course, we can cross multiply. Okay, we can cross multiply on this part. So this is gonna give us 75 tangent 40 plus x. Yeah, 75 tangent 40 plus x. Okay, multiplied to tangent 20 is gonna be equal to x tangent 40. Okay, so now we have this equation, this long equation here. And then we can also say that we can distribute tangent 20 at this part. So this is going to give us, if we're going to continue here, so that's going to be 75 tangent 40 multiplied to tangent 20. Okay, 75 tangent 40 tangent 20 plus x tangent 20 is going to be equal to x tangent 40. And then since we have here two like terms, so that's x tangent 20 and x tangent 40, we can transfer x tangent 20 to the other side. So that's going to give us 75 tangent 40 tangent 20 is equal to x tangent 40 minus x tangent 20. And now for this problem, we can factor out the x because that's the one we want. That's the variable that we want to solve for this problem. So that's going to be x tangent 40 minus tangent 20. And that's going to be equal all to this part. 75 tangent 40 plus 75 tangent 40 tangent 20. And to solve for the value of x, we just have to divide both sides by tangent 40 minus tangent 20 for this one. So this will give us, okay, a very long value, a very long expression. So therefore x, the value of x for this one, let's write it here on the ground. Okay, so the value of x is gonna be 75 tangent 40 tangent 20 all over tangent 40 minus tangent 20. And if we're going to evaluate this using our calculator, so this is gonna give us 75 tangent 40 multiplied to tangent 20. Okay, 75 times tangent 40 times tangent 20 all over tangent 40 minus tangent 20. And that should give us approximately equal to the approximate value of the height. Okay, the approximate value of the height of this parachute to the ground is gonna be x. Okay, the approximate value is 48.21. Okay, so that's gonna be 48.21 feet. If we evaluate this complete value here, it's gonna give us that x, or the distance between the ground and the parachute, given only these measurements, these indirect measurements, it's gonna give us 48.21 feet. And that's how we solved it for our last problem for the last module in the third quarter.